Uh, let's concentrate on this question, which is question on Euclidean geometry. So we are given in the figure AQ is parallel to RT. Here is our AQ. Here is our RT. So it's fine. Then you are also given that BQ is to QC. So we go there. Here is our BQ. Is to our QC. They said is 3:5. But we are going to put a variable. Since it's not the actual distance, it's a ratio. So a ratio, we normally show it by putting a variable so that we don't confuse it with the actual length. Then we are further given that BR is to RA here. It's our BR is to RA, this part. They said it's 1 is to 2. So we can put another variable different from the first one. We have that. Then the first part is saying if BT is equal to K, this is BT is equal to K, TQ, calculate TQ in terms of K. So here, BT is here, TQ is here. So we are going to concentrate on this triangle. We are going to concentrate on this triangle. But if we check in that particular triangle, we have a side, a line which is parallel to third side, this one. So the moment we have a line parallel to third side, we must think of proportionality theorem. So let's go to question 8.1. Question 8.1. We are told that BT, which is this one, we are told that is K. So we can write the ratio BT. Then they want you to calculate TQ. Here is our TQ. Here, this part. So it means here we can apply proportionality theorem. So we can write TQ divided by BT must be equal to, so if we are to check in this triangle, which is now in red, we have this pair of parallel lines. So TQ is gonna move with RA, then divided by this BT gonna move with BR. What's the reason? It's proportionality theorem. Proportionality theorem, which sides are parallel? We are told that AQ is parallel to RT. There, but initially we are given the ratio BR as to RA. So if we want RA as to BR, we just invert this one. It's 2 over 1. So it means where there is TQ is the one that we want to calculate, must be over BT. BT we are told is K. This must be equal to 2 over 1. So it would therefore mean that TQ it would therefore mean that TQ, if we cross multiply, is equal to 2K. TQ is equal to 2K. So if we are to check, it therefore means that this part is equal to 2K. But if we add BQ, that ratio, now is the actual distance. This is now the actual distance. It means it's now 3K. So if we now want to get the actual distance of QC, we can now use the ratio that we are given here of 5:3. So yeah, we can therefore conclude that, okay, we can therefore conclude that this part, if we check here, we were given 3:5, and here we are now having 3K, which is K plus 2K, which is 3K, which is this part. So it therefore means this part Q will be represented by 5K, that part, based on our calculations that we already did. Then we go to the next question. What is the next question saying? It's saying hence or otherwise calculate the numerical value of CP over PR. CP over PR. So for that one, we are now going to come to this particular triangle. There's this one, CP over PR. So we are going to come to this particular triangle. Which is now in blue. This particular triangle. And if we are to check, this side is parallel to this side. It's given. We are now concentrating the triangle that is in blue. So we go to 8.2. We go to 8.2. So on 8.2.1, we are going to talk of CP divided by PR. So that will be equal to, we'll check CP, PR is a straight line and we have got parallel lines on that. Meaning that we have if we concentrate on triangle CRT, we realize we have a side parallel to the third side. So we still use the proportionality theorem. So CP gonna be CQ divided by PR gonna be QT. And what's the reason for that? It's proportionality theorem. It's proportionality theorem. Which sides are parallel? AQ is parallel RT. So eventually our CP over our PR will be equal to CQ. Here is our CQ. So it's 5K divided by our QT, which is 2K. Then the K will divide. So it therefore means our CP over our PR is equal to 5 over 2. Then we go to 8.2.2 there. It's saying determine the ratio of area of triangle RCT divided by area of triangle ABC. But here we are going to check. We are going to check the triangles that we are talking about. We are talking of triangle RCT. Here is triangle RCT. Here is triangle RCT. Oh, sorry. RCT. That's the triangle. And then the other triangle. So RCT is this one in green. Then we check the other one, which is ABC. Triangle ABC. Let me put it in yellow. This is triangle ABC. So we are going to check a lot of different things when we go to ratios of a triangle. We can check, are these triangles between parallel lines? As you can see, yes, parallel lines are there, but they are not between parallel lines. Then we can check, are they sharing any common angle? As you can see, we can check properties of similarity. There are many approaches that we can use when solving these ratios of triangles, of areas of triangle. But all those things that we check, maybe they are not there. Another thing that you can check here, we can go beyond just those two triangles and check any other relationship. So in other words, in this case, we can see that the area of triangle BRT, if you check that BRT is sharing a common angle with the triangle ABC. So it's easier for us to deal with that. Then we can also go and check triangle ARC. The triangle ARC. If we are to check triangle ARC and compared to triangle ABC, they have something in common, so we can, they have a common angle there, so it's easier to deal with that. Then plus the triangle R, the area of triangle RCT, which is the one that is in question, you'd realize that if we add those areas, they are going to give us the area of triangle ABC. So we are saying the area of this triangle here plus the area of this triangle here plus the area of this triangle here. They'll give us the area of the whole triangle ABC. Right. So, using that, but remember we want a ratio. So to incorporate a ratio, we are going to divide throughout by the area of triangle ABC. Divide here by the area of triangle ABC. Divide here by the area of triangle ABC. Divide here by the area of triangle ABC. So what is it that we did? Why did we divide by area of triangle ABC? We want to come up with this ratio. So in this case, this ratio is now accommodated here. The required ratio is now accommodated there. So we can now solve. Let us go and check. If we check BRT, which is this one, triangle BRT, it's having a common angle. So using the area rule, we can use that common angle. So to get the area of triangle BRT there, we can write it as, remember, using area rule says that area of triangle we are going to use the area rule, and we know that if we are to use the area rule, the area of triangle ABC is given by half A B sine C. This C is the included angle. So using that, we are now going to answer that question. So it means area of BRT here, BRT, and area of ABC. Using area rule, they have a common angle there, which is B. So we are now going to say area is half AB. So we are going to use this side, which is going to be 1y times the other side here, BT, which is K, multiplied by sine B, all over area of triangle ABC is going to be half. Because we want to use this angle sine B, so we are going to take this side AB. So the total of AB is 2y plus y, which is going to give us 3y multiplied by this whole side BC is going to be K plus 2K, which is 3K, plus 5K, which is 8K, times sine B, plus we go to triangle ARC, so we want to use the common angle there, that big A, this angle there, between ARC and ABC. So it will mean that the area of triangle ARC will be half yes, will be 1 over 2 multiplied by this side AR, which is gonna be 2y multiplied by that side AC multiplied by sine included angle, which is sine A, all over Area of triangle ABC is going to be half. But take note here, we are now going to use A as our included angle. So it means we will need this side, this entire side for A. BC, this whole side is going to be 2y plus y, which is 3y, times this side. So that will make our angle A included, AC, times sine A. Then it's going to be plus this ratio, which is our required ratio, which is area of triangle RCT divided by area of triangle ABC. This must be equal to area of triangle ABC divided by area of triangle ABC. We get 1. Any number divided by itself, any variable divided by itself is 1. So simplifying that, it means we are going to divide here. The half and the half are going to cancel out. The y and the y there will cancel out. The k and the k there will cancel out. The sine b and the sine b will cancel out. So it will imply that if we simplify this, on our numerator, we are left with 1 times 1 times 1 times 1. So it's going to be 1 over. On the denominator, we are left with 1 times 3 times 8 times 1. So 3 times 8 is going to be 24. Plus, let's simplify here. So the half and the half are going to divide each other. The y and the y are going to divide each other. The AC and the AC will divide. The sine A and the sine A will divide. So we would realize that on our numerator, we are left with 1 times 2 times 1 times 1, which is going to give us 2 over. Here it's 1 times 3 times 1 times 1. So it's giving us 2 over 3. Then it's going to say plus that triangle RCT divided by triangle ABC must be equal to 1. Then from there, we can make that the subject of the formula. We can now make that the subject of the formula. So it therefore means that, therefore, our triangle RCT divided by the area of triangle ABC will be equal to 1 minus, we are going to transpose these two. Take this one to that side, take this one to this side. So it's going to be minus 1 over 24 minus 2 over 3. Then we can use the calculator. Let's check the calculator. So using the calculator, we are going to get 1 minus 1 over 24 minus 2 over 3. So eventually our final answer is 7 over 24. So it will mean that triangle RCT, area of triangle RCT is to area of triangle ABC will be equal to 7/24. Thank you.